Hey everyone, welcome to our video on understanding polynomials. Whether you're just starting out or need a quick refresher, this video will guide you through the basics of polynomials step by step. Let's dive in. Let's start with the basics. A polynomial is an algebraic expression made up of variables, coefficients, and exponents. These are combined using addition, subtraction, and multiplication. But remember, the exponents must be whole numbers like 0, 1, 2, 3, and so on. Now, let's break down the parts of a polynomial. A term is a single part of a polynomial like 3x, -4, or 5x squared. The coefficient is the number in front of the variable like 3 and 3x. The variable is the letter, like x. The exponent is the power of the variable, like 2 and x squared. And finally, a constant is a number without a variable, like 7. Here are some examples of polynomials. 2x squared plus 5x minus 7 is a polynomial with 3 terms. X cubed minus 3x squared plus 5x minus 8 is a polynomial of degree 3. 7y plus 6 is a polynomial of degree 1. These are all valid polynomials because they follow the rules we just discussed. But not all expressions are polynomials. Here are some non-examples. 3x to the power of negative. 1 plus 2 is not a polynomial because the exponent -1 is not a whole number. 4 divided by x plus x squared is not a polynomial because the variable is in the denominator. Remember, polynomials can't have negative exponents or variables in the denominator. Now, let's talk about how we classify polynomials. First, we can classify them based on the number of terms. A monomial has 1 term, like 5x cubed. A binomial has 2 terms, like x squared minus 3x. A trinomial has 3 terms, like x cubed plus 2x minus 4. If a polynomial has more than 3 terms, we just call it a polynomial. Next, we can classify polynomials based on their degree. The degree of a polynomial is the highest exponent of the variable. A constant polynomial has degree 0, like 7. A linear polynomial has degree 1, like 2x plus 3. A quadratic polynomial has degree 2, like x squared minus 4x plus 4. A cubic polynomial has degree 3, like 5x cubed. Finally, let's talk about ordering polynomial terms. By convention, we list polynomial terms in order of decreasing exponents. For example, 3x cubed plus 5x squared minus 2x minus 4 is written in standard order with the highest exponent first. This makes it easier to read and work with. Let's begin operations on polynomials with addition and subtraction of polynomials. To add or subtract polynomials, we combine like terms. Like terms are terms that have the same variables with the same exponents. For example, to add 3x squared plus 2x minus 5 and 4x squared minus x plus 3, we combine like terms. 3x squared plus 4x squared gives 7x squared. 2x minus x gives x. -5 plus 3 gives -2, so the result is 7x squared plus x minus 2. Next, let's look at multiplying polynomials. First, we'll multiply a monomial by a polynomial. To do this, we multiply each term in the polynomial by the monomial. For example, 3x multiplied by 2x squared plus 4x minus 5 gives 3x times 2x squared equals 6x cubed. 3x times 4x equals 12x squared. 3x times -5 equals -15x. So the result is 6x cubed plus 12x squared minus 15x. Now let's multiply 2 binomials. We use the distributive property, which means we multiply each term in the first binomial by each term in the second binomial. For example, to multiply x plus 2 by x plus 3, we do x times x equals x squared. X times 3 equals 3x. 2 times x equals 2x. 2 times 3 equals 6. Combine like terms, 3x plus 2x equals 5x. So the result is x squared plus 5x plus 6. Now, let's move on to division of polynomials. First, we'll divide a polynomial by a monomial. To do this, we divide each term in the polynomial by the monomial. For example, 9x cubed plus 6, x squared minus 3, x divided by 3x gives 9x cubed divided by 3x equals 3x squared. 6x squared divided by 3x equals 2x. Negative 3x divided by 3x equals negative 1. So the result is 3x squared plus 2x minus 1. Next, we'll divide a polynomial by a binomial using long division. Long division for polynomials works similarly to long division with numbers. We'll divide the polynomial term by term, multiply, subtract, and repeat until we reach a remainder that's either 0 or of a lower degree than the divisor. Let's look at an example to understand this better. Here's our first example. We need to divide 2x squared minus 7x plus 6 by x minus 2. Let's break this down step by step. Step 1. Divide the first term. We start by dividing the first term of the polynomial, 2x squared, by the first term of the divisor, x. 2x squared divided by x gives 2x. This 2x is the first term of our quotient. Step 2. Multiply. Now we multiply the entire divisor, x minus 2, by the term we just found, 2x. 2x times x gives 2x squared. 2x times negative 2 gives negative 4x. So we get 2x squared minus 4x. Step 3. Subtract. We subtract 2x squared minus 4x from the original polynomial, 2x squared minus 7x plus 6. 2x squared minus 2x squared cancels out to 0. Negative 7x minus negative 4x gives negative 3x. 6 minus 0 gives 6. So after subtraction, we have negative 3x plus 6. Step 4. Repeat the process. Now we take the new polynomial, negative 3x plus 6, and divide its first term, negative 3x, by the first term of the divisor, x. Negative 3x divided by x gives negative 3. This negative 3 is the next term in our quotient. Step 5. Multiply again. We multiply the entire divisor, x minus 2, by the new term, negative 3. Negative 3 times x gives negative 3x. Negative 3 times negative 2 gives positive 6. So we get negative 3x plus 6. Step 6. Subtract again. We subtract negative 3x plus 6 from the current polynomial. Negative 3x plus 6. Negative 3x minus negative 3x cancels out to 0. 6 minus 6 also cancels out to 0. So we're left with 0, which means there's no remainder. Final result. The quotient is 2x minus 3, and the remainder is 0. So 2x squared minus 7x plus 6 divided by x minus 2 equals 2x minus 3. Now let's try a slightly more complex example. We'll divide x cubed plus 2x squared minus 4x minus 1 by x minus 1. We'll follow the same steps as before. Step 1. Divide the first term. Divide x cubed by x to get x squared. This x squared is the first term of our quotient. Step 2. Multiply. Multiply x squared by x minus 1 to get x cubed minus x squared. Step 3. Subtract. Subtract x cubed minus x squared from x cubed plus 2x squared minus 4, x minus 1. This leaves us with 3x squared minus 4, x minus 1. Divide 3x squared by x to get 3x. This 3x is the next term in our quotient. Multiply 3x by x minus 1 to get 3x squared minus 3x. Subtract 3x squared minus 3x from 3x squared minus 4, x minus 1. This leaves us with negative x minus 1. Divide negative x by x to get negative 1. This negative 1 is the next term in our quotient. Multiply negative 1 by x minus 1 to get negative x plus 1. Subtract negative x plus 1 from negative x minus 1. This leaves us with negative 2 as the remainder. Final result, the quotient is x squared plus 3x minus 1, and the remainder is negative 2. And that's it. We've covered the basics of polynomials, from understanding what they are and their parts, to classifying them, and even performing operations like addition, subtraction, multiplication, and division. Polynomials might seem tricky at first, but with practice, you'll get the hang of it in no time. If you found this video helpful, don't forget to give it a thumbs up, share it with your friends, and subscribe to our channel for more math tutorials like this one. Drop a comment below if you have any questions or want to see more examples. We'd love to hear from you. Thanks for watching. See you in the next video.